So we will see some more examples on construction of the DFA. Here I have drawn the diagram. The conditions, the first question is, for even number of A's and even number of B's, we have to construct the DFA. So here we have taken the single example. So whereas in this single examples, we will construct. So all based on this the given question. So here we have taken Q0, Q1, Q2, Q2, Q3, all these are the 4 states. The input alphabets are A and B. The initial state is Q0. So here still I have not given the final state. So based on the question, we have to give the final state. First one, for even number of A's and even number of B's. Whatever the DFA that we have constructed, that has to accept all the strings like even number of A's and even number of B's. That means maybe 0 A's and 0 B's, maybe 2 A's, 2 B's, maybe only the 2 A's, maybe only the 2 B's, like 4 A's, maybe 4 B's. So based on this, etc. So based on the strings, we have to construct the DFA. So first come to the initial state. So on initial state Q0, the transition A to Q1, and again we have one more A from Q1 to Q0. So look at the diagram. Whenever from Q0 to Q1, we will transmit from the single A. From Q1 to Q0, so again we have single A. That means to reach from Q0 to again Q0, we need to transfer 2 A's, Q0 to Q1 and again Q1 to Q0. That means whenever we are at the final state of the Q0 and the initial state, the same initial state and the final state, we have accepted the first 2 A's. Check for the 2 B's again. So from Q0 again we have B. The next state is Q2. From again Q2 to the next state, we have again Q0. We have started from the Q0 and we are ended up with the Q0. That means we all know that it is the initial state Q0. So if you make the Q0 as the final state, it satisfies the 2 B's also. And we will check one more, A and BB. So start from the Q0. So A means we have to transmit Q1. Again next A means Q1 to Q0, B means from Q0 to Q2 and again Q2 to Q0. Again we have stopped from Q0. So that means whenever we make Q0 as the final state, check all the strings. So like 4 A's. So 1, 2, 3, 4. If you transmit from Q0 to Q1, so it satisfies the many number of even number of A's and 1, 2, 3, 4, 4 A's and 4 B's. Like that even number of A's and even number of B's will satisfy it in the diagram whenever Q0 is the initial state and Q0 is the final state. So write down, whenever Q0 is initial and Q0 is final, so it satisfies for even number of A's and even number of B's. Now next one more question we have. For odd number of A's and even number of B's, we have to construct the DFA. So here we will remove the Q0 because Q0 is the initial state. This is our as usual one. So now we have to check it. So it has to satisfy odd number of A's and even number of B's. Start from the Q0. So first write the strings that satisfy with the odd number of A's, that is A, and even number of B's, that means maybe the 0 B's. Maybe the 0 B's, that means single A, maybe the single A, maybe odd number of A's means maybe 2 B's. So 3 A's, 2 B's. Odd number of A's, even number of B's. Maybe 3 A's, 4 B's. Like that we have to satisfy. So now check it. For odd number of A's. So here is also the Q naught is the initial state. We have to move from the Q naught or input alphabet A Q1. So whenever you make Q1 as the final state, so it satisfies first string. Check it as 2 B's. So sorry, odd number of A's means, so at least the single A, B, B. So check from Q naught A, B, B, we have transmitted to Q3 and again B. So again we are stopping at the Q1. So A, B, B, it's satisfied whenever Q1 is the final state. Next, check triple A's and 2 B's. Triple A's means 1, 2, 3. Always we are starting from the Q naught because it is the initial state. 3 A's, again we came up to the Q1 and 2 B's. So here we have taken the string 2 B's, right? So 1 B, 2 B. Again we have stopped at the Q1. So shall we make it as the final state? So Q1 is the final state. So whenever we make it as the Q1 as the final state, it satisfies all the strings. So whenever we have odd number of A's and even number of B's. So that means whenever, so Q1 is the final state, it satisfies odd number of A's and even number of B's. The transition diagram and the whole DFA diagram is same for all these, but the final state is different. Whenever we make Q naught as the final state, so initial state and the final state is the same. So for even number of A's and even number of B's. Whenever we done the Q1 as the final state, it satisfies all the odd number of A's and even number of B's. Next, let me check whenever Q3 is the final, Q2 is the final state. So Q1, make it as same. So now check for even number of A's and odd number of B's. So for even number of A's, that means 0 A's or 2 A's and odd number of B. Maybe single B, maybe 3 B's, maybe even number of A's means 4 A's, maybe odd number of B's, 5 B's, like that. So it has to satisfy this type of the strings. So for even number of A's and odd number of B's, we are checking this condition. So 2 A's, start from the initial state Q naught. 2 A's means Q naught to Q1, again Q1 to Q naught. Okay, 2 A's. And single B means we have to transmit from Q naught to Q2. So Q naught A, Q naught to Q1 A, Q1 to Q2 A. And again B means come to Q2. So whenever we are at Q2, this thing is satisfied. Now check 2 A's and 3 B's. So that means even number of A's, 2 A's, odd number of B's. So 1, 2, 2 A's, 1, 2, again 3, again we are at the Q2. This string is satisfied. Now check 4 A's and 5 B's. Because 4 A's even number of A's, odd number of B's. 1, second A, third A and fourth A. 4 A's, we are at Q naught. And check 5 B's. 1, 2, 3, 4, 5. We are at Q2. That means whenever we are at the Q naught as the initial state, Q2 has the final state. It has satisfied even number of A's and odd number of B's. Next, let me check for odd number of A's and odd number of B's. Now, Q2 is the normal state. So here, check it. Odd number of A's means single A. Odd number of B's means single B, or otherwise 3 A's, 3 B's, 3 A's or single B, 3 A's or 5 B's or any type, etc. Right? So this type of the string has to satisfy. So then we have to construct this DFA. So again is Q0 is the initial state. Let me check first one. A means single A from Q0 to Q1, A. And again we have to check B. B means Q1 to B here. So whenever we are transmitting A, we are at Q1, and we have to transmit B, we are at Q3. So that means whenever we are at the final state, it satisfies the first string. So check another string, 3 A's and 3 B's. Again we are starting from the Q0 because it is the initial state. Don't forget this, Q0 to Q1 A, 2, 3, 3 A's, and we are at the Q1, we have to transmit 3 B's, 1, 2, 3 B's. So we are at Q3. So whenever we are at Q3 final state, satisfy this string. Next 3 A's and single B, 1, 2, 3, single B is satisfied. So 3 A's and 5 B's, 1, 2, 3, 3 A's, we are at Q1, 1, 2, 3, 4, 5. So that means whenever we make Q3 as the final state, it satisfies all these strings. That means here whenever we are at the Q2 as the final state, it satisfied even number of A's and odd number of B's. Whenever Q3 as the final state, it satisfied odd number of A's and odd number of B's. Like that we have to construct this DFA. The transitions and all the same. Whenever it changes the final state, automatically the condition makes it different. So based on the condition, we have to make the final state. So this is the construction of the DFA. So whenever we are constructing the DFA, we have to check for the same input alphabet, we need only the single transition. So when Q0 on input alphabet A, Q1 on input alphabet B, so Q2. So there is only the on the different input alphabets we have the different transitions. So that is the construction of the DFA. Now we will go with the simple example, A power M, B power N. So now we have to construct the DFA based on this condition. That means any number of A's and any number of B's, it has to satisfy the DFA. Q0, Q1. So next again we have Q2. So any number of A's means single A or many B's or many A's or single B or many A's or many B's. So these are the strings. So based on this we have to construct. So let me check. First we have to transmit A, right? Because A power M, B power N, A. And next one, so we have to transmit B's. So at the B we have to start, that is the final state. So we have to indicate the initial state. Q0 is the initial state. So A power M. So any number of A's. So already B we have transmitted from Q1. So again we should not transmit because it is a DFA. We have to transmit A itself. So based on this we can write, so any number of A's, right, and a single B. And again it satisfies many number of B's because B power N. So that can we make it as this B. So now it satisfies many number of A's because it has the self loop, and many number of B's because B has the self loop to Q. Like that we have to construct the DFA. Next, for suppose on Q0 we have transmitted input alphabet A. For suppose if you want to transmit B, you have to go to another state. So we should not give here because so whenever you give like this, so it not satisfy A power M, B power N. So we have to should not give like this. We have to go with the transmission to the next states itself like this. So A, B. So Q1, so we have transition A and B. Q2, we have transmission B. So for suppose we want to transmit A, we have to come here. So this, from this state we can't move to the another state, right? So this we are calling it as the dead state. So it is not the mandatory. So you can go with up to here itself. So you can check it satisfied A power M, B power N. That means any number of A's and any number of B's. Like that you have to construct the DFA. You have to remember that DFA that contains some single input alphabet. So we have only the single transition on the same input alphabet. Right? So that is the construction of the DFA.